Right. Hello, Algebra 1. Today we're going to be beginning the third part of Chapter 3. So remember what we've done so far. What we've done so far is exponents and then using algebra tiles. Today what we're going to be looking at is how are we going to be solving equations. So today is about finding x. And so what I want everybody to do, we're not going to do a warm up today. I want you to just skip to that question 372. And notice what the directions tell you. They tell you to solve by drawing a generic rectangle to help you rewrite the products. So solve by drawing a generic rectangle. That's something that you've done all week last week. Can you create a generic rectangle and then help you? The generic rectangles that will help you know how to solve for x. So let's take a look at this first one. We need to, this one, we're actually solving for y in this first one, but we need to get y, or the variable, by itself. Now you have two options. You can use the distribution property, like we talked about last week, where you're taking that 2 and you are distributing it, okay? And then you're going to solve for y. Or you can use your generic rectangle. And that's what I'm going to be focusing on today. So if you use distribution, that's fine. But I caution you, as these distribution problems get harder and harder, the more we're going to ask you to use your generic rectangles. So I'm going to always start with generic rectangles. Here's what my generic rectangle looks like. I have a height of 2, and I have a width or length of y minus 2. And then I just go through and I do all the multiplication that we did last week. So 2 times y is 2y, that's the area of that rectangle. And the area of this rectangle is negative 2 times 2, which is a negative 4. All right, and so now I know my answer. Okay, well, I don't have to know my answer. What I've done is I have rewritten that left-hand side. So I know that the left-hand side now is 2y minus 4 equals a negative 6. And now you get to go through and solve like you normally would any problem like this. So how do I get rid of a negative 4? Well, I have to undo that and I'm going to add 4. So then I get 2y on this side, those go to 0. Negative 6 plus 4 gives me a negative 2. I divide by 2 and I get y equals a negative 1. Now, on this type of problem, you do not need to ask your Mrs. O'Day or I if you got the right answer. You can check it yourself. So if you get yourself some space, I want you to actually do the work to check. So we said, oh, we got negative 1 as our answer. So wherever I see a y, I'm plugging in that negative 1. So do my PEMDAS. Negative 1 minus 2 is negative 3. 2 times a negative 3 is negative 6. Negative 6 equals 6. I got the right answer. Okay, so notice, you can check your own work. And this is true for our next short cycle, which happens to be next week, is that you can do that. You do not have to rely on us to check your work. Take your time to do that. Okay. Next question. We have 5x squared plus 43 equals a product, the length times the width. And I have to somehow get all of the x's together. And I want you to notice, we now have an x squared in there, and we haven't really asked you to solve things for x squared. And so this is why it's really important to be able to rewrite something to help you understand it. So let's rewrite this left-hand side. 5x plus 43 equals, now I know that right-hand side is a product. It's a length times a width. And so I'm just going to use my generic rectangle to help me with that. So my length is x minus 1. My height is 5x plus 6. And now I'm going to fill that in. Okay, so I have 5x times x gives me 5x squared 6 times x gives me 6x. Negative 1 times 6 gives me negative 6. Negative 1 times 5x gives me 5x. Now remember, that's the reason we use our generic rectangles is to help us find the product quickly. It helps us organize our work and it helps us find all of the pieces. Don't forget that you have how many x's. That's the part that students tend to forget. And so my left-hand side didn't change, but now my right-hand side is 5x squared. Notice all we're doing is writing what's the area as a sum here. How many total x's do you have? Well, you have 6x plus 5x. That's 11x, and I have a negative 6 for my units. This is looking much better in terms of solving for x. I can now take the time and check this. So I can now get rid of a couple of things. Oh, look at what happens to our x squareds. If I try to get my x squareds together, look at what happens. Magic happens. So you have 5x squared minus 5x squared. That goes to 0 and you're left with 43. Oh, but look at that. 5x squared minus 5x squared. That goes to 0 and you're left with 11x minus 6. Okay, so let's add 6 to each side. Remember, my goal is to get all of my x's by themselves. Okay, so 43 plus 6 gives me 49 equals 11x. Oh, you guys didn't catch me. What's a negative 1 times 5x? That's a negative 5. So this means I only have 1x. Oh my gosh, you guys didn't even catch me. So that means we have 49. Okay, equals 1x. Guess what that means, guys? X equals 49. I apologize. See what happens when you don't take care of your negatives? You get to do a Mrs. Alpha. So remember, it's negative 5x plus 6. That just leaves us with 1x. So my 1x does equal 49. Now what I want you to do, guys, is I want you to check it. Plug 49 back into that crazy equation and see if it works. Okay. All right. We're going to let you guys try C and D on your own. Now I'm going to help you set up C, but then I'm going to have the video be paused and everybody's going to work through C and D. So take a look at C. Look at the left-hand side and look at the right-hand side. We now have two products that we're dealing with. So I have to be able to write them as a sum to be able to get X by itself. So what I'm going to do is I'm going to rewrite these guys to help me understand the problem better. If the way it looks is confusing, stop and rewrite the problem. You can always make it look easier. So I have an X plus 3 and an X plus 4. That's my length and my width. On the right-hand side, I have an X plus 1 and an X plus 2. Okay, go through, do your multiplication, set up the equation as the area of a sum equals the area of the sum, and see if you can get all of your X's together. Raise your hand when you're done. We'll come check your work. But remember, you can always check your answer. And then once you know you have C right, move on to D. All right, welcome back, Algebra 1. Here are the solutions for those two problems. I know when you get done with C, you get a fraction, negative 10/4. And when you reduce it, you get negative 5/2 or negative 2.5. And so sometimes you wonder like, oh, I got a fraction. Is that right? Is it negative? And so here's what I want you guys to just see. I typed that into my calculator, and all I did was I put a negative 2.5 in for X. The top one represents the left-hand side. The bottom equation right here represents the right-hand side. And I'm looking to see, does the left equal the right? It does. They both sides equal 0.75. So that's the right answer, even though it is a decimal. Okay. All right, guys, I'm going to have you turn your page over. And because this now represents another type of equation that you're going to have to get good in solving. And so one of the things that we're going to talk about is absolute value. Now, before we jump into absolute value equations, we've not ever done absolute value equations. We've done expressions. You've never been asked to solve. I want you to remind yourself, what is absolute value? Okay, so absolute value tells us how far away we are from zero. If I run 2 miles to the east, okay, I've run 2 miles. If I run 2 miles to the west, I have still run 2 miles. It doesn't matter that I've gone in the opposite direction. So I always think of a number line. How many different ways can you get to zero running 2 miles? Well, I can go this direction, or I could go that direction. There are always 2 ways to get to zero. I can come from the east, I can come from the west, okay? So on this guy here, we're looking for, then again, we're going to recall this, that the absolute value of 11 equals 11, okay? And also that the absolute value of negative 11 equals 11, okay? So there are, again, if I ran 11 miles, it doesn't matter if it's a negative 11, meaning it's coming from the opposite direction. So now you're going to see things that look like this. Solve for x. So what happens if you have x, the absolute value of x equals, we'll say 7. What could you possibly put in those absolute value signs to give you 7? Well, let's think about that. We know that x could be a positive 7, right? And x could be a negative 7. So let's write that out. If I put 7 in for x, the absolute value of 7 is 7. And if I put negative 7 in for x, I still get 7. Notice there are 2 different answers here. Whenever you get an absolute value equation, you will always have 2 different answers. Unless it's impossible, you'll see some that we make no solutions, but if there's a solution, there will be 2, okay? And so we're going to try 6 problems, and you'll notice the hint, one of them does not have a solution. Okay, so what I want you to do is, given this problem, we're going to pause the video here, and I want you to think about, what could I put in for x so that I get an answer of 5? Pause the video. Everybody try this problem. All right, welcome back, Algebra 1. So your answer should look something like this. You should be able to put in 5 and negative 5, and you will get, those are the 2 possible answers. Okay, let's look at B. So we always increase the difficulty. So what happens if you get a problem that looks like this? Now, the first thing you have to ask yourself is, the absolute value sign with what's ever on the inside, is it by itself? Is there anything on the outside? Is there anything kind of making this more confusing? Well, in this case, yes. There is a 2 on the outside of those absolute value signs. And remember, this is saying 2 times x. So how do I get the 2 away? I have to get the absolute value sign to be by itself before I can solve this problem. So think about, this is 2 times the absolute value of x. How do I undo times? I divide. So then I get this. The absolute value of x, because 2 divided by 2 is just 1. The absolute value of x is 20. Okay, from this point, we're going to pause the video and you solve for X. What two values of X can I put in those absolute value signs to get an answer of 20? Okay, guys, you should be getting X is 20 and X equals negative 20. If I put those in, I absolutely will get the correct answer. And you can always put them back. You can check, put them back into the original problem. Because if I take the absolute value of 20, that's 20 times 2 is 40, which was our original problem. But if I put in negative 20, the absolute value of negative 20 is also 20. 20 times 2 is a positive 40. Okay, let's try the next layer of difficulty, guys. What happens if you get this? What is the absolute value of X equal to negative 2? Our goal is to find what number can I put in for X so I will get an answer of negative 2. Well, so let's try it. Let's put in 2. Well, the absolute value of 2 is 2. Well, that doesn't work out so well because I need it to be negative. If I put in the absolute value of negative 2, that's also 2. This is not equal to a negative 2. So is it possible to get a negative answer like this? Okay. I cannot take the absolute value of any number and get a negative output. And so on this one, what we put is no solution. All right, so there's our last one. There's our only one that has no solution. Okay, let's try D, because now D is going to get a little bit more tricky because we're going to start throwing stuff on the inside. Okay, we're going to throw some things on the inside of that absolute value. And so you have to think about, okay, what's happening here? I need to put something in for X to make this problem work, okay? And so I have to think about what can I substitute in for X so that I get a positive 10. Now, let's just pretend, we're just pretending right now that I gave you that problem, okay? I just said, what's the absolute value of X? And everybody in the room is going to be like, oh, that's so easy, Mrs. Tal, but it's just 10 and negative 10. I can plug in both of those and you would be right. Because if I took the absolute value of 10, I get 10. If I take the absolute value of negative 10, I get 10. And so what you're trying to do is that you're trying to force the inside of the absolute value. It does not matter what's inside of that absolute value. You're trying to force what's on the inside to be 10 or negative 10. And this is where you're going to see me have two different cases, okay? I'm going to call this positive case. I'm going to set the inside equal to positive 10. Notice I don't care about the absolute value right now. I don't even have the absolute value down. What I care about is what's on the inside. And so the inside is X minus 7. And that's what I'm trying to make to be 10. So I add 7 and I get X equal to 17. So we know X equal to 17 is one of those answers. Now be careful, because here's a very common thing that students love to do. They'll be like, oh, it's X equals 17 and X equals negative 17, and they just leave it. Be careful. Not all of our problems work out so nicely. It's pretty rare when our problems work out that nicely and that's symmetric, like it's just positive and negative, because you have to check the negative case. And here's the negative case. Remember, I'm trying to force the inside to be negative 10, because if I can force the inside to be negative 10, the absolute value of negative 10 is 10. So all I do is I take what's on the inside, X minus 7. Notice I didn't change what's on the inside. That's what's on the inside. But this time, I'm trying to force it to be a negative 10. Notice that's the only difference between the positive and negative case. One is set to 10, one is set to negative 10. And then I'm going to notice the same step. I'm going to add 7, but here's where you have to be careful. Negative 10 plus 7 gives us a negative 3. So here are our two answers. Now again, you're going to have time to check yourself. So please check. So let's check this one. Here's my original problem. And my claim is that x equals 17 and x equals a negative 3. That's my claim. Okay, and I'm going to check that. So I'm going to plug this in. 17 minus 7 equals 10. Is that true? Well, let's do the math. 17 minus 7 is 10. The absolute value of 10 is 10. Boom. That one worked out. Check mark. Okay, let's try the negative case. Again, I'm saying negative 3 minus 7 equals 10. We have to check, is that true? I'm just plugging in, wherever I see an x, I'm plugging in that negative 3. So negative 3 minus 7 is negative 10. Is the absolute value of negative 10 10? Yes. Absolute value of negative 10 is 10. Okay, so I did my math correctly. Okay, so here's what you're going to need to do. We're going to challenge you to do these next two. I will help you set up the positive and negative case for part C. Okay. But then you're going to get to try to figure them out for yourself. So part E. So we have the absolute value of 3x minus 5 equals 16. So remember the goal. The goal is I'm trying to force the inside to be a positive 16. Then I'm going to try to force the inside to be a negative 16 because that's where I'm headed. I need the positive and negative case. The absolute value of 16 is 16. The absolute value of negative 16 is 16. So I'm going to do the positive case. I'm going to take what's on the inside and set it equal to a positive 16. Then I'm going to take that, this is the negative case now. I'm going to take the exact inside, but this time I'm going to set it to a negative 16. Okay, we're going to pause the video here. You guys need to go through this. You need to go through it and then check your answers at the end, but see if you can solve for x. What two values can I put in for x to make it 16? Okay, welcome back, Algebra 1. These are the two answers you should be getting. Now remember, if I plug 7 in, I should get the absolute value of 16 is 16. You plug that in and it works. When you plug in, yes, negative 11/3, notice that's an ugly number, but you can still work with it, guys. Check my calculator, okay? So here's my calculator work. I wanted to see if the inside really does equal 16. And sure enough, it does. When I plug in a negative 11/3, oh, that equals negative 16. All I have to do is now take the absolute value. Absolute value of 16 is 16. The absolute value of negative 16 is 16. Even when you get crazy numbers like negative 11/3, put them into your calculator and you will see, you will get that. You can check, okay? And there it is. Okay, last problem, guys. And have you set this one up by yourself? What is the absolute value? So we have the absolute value of 7 minus 8x equals 1. What values of x can I plug into that absolute value to make it equal 1? All right, we're going to pause the video again. Try this one all on your own. All right, last time to check your answers. You should be getting x equal to a positive 3/4 or 0.75 and x equal to 1. Again, if you're not sure, did I do that right? Plug your answers into a calculator. You should be getting 1 and negative 1, and then you just take the absolute value, okay? So all I did was I plugged in, okay, 0.75 into here, and I got 1. The absolute value of 1 is 1. Then I came and I plugged in 1, and I get 7 minus 8 is negative 1. which is what my calculator shows me, but the absolute value of -1 is 1. So I know my answers are correct. These absolute value problems take a while to understand, and we'll be practicing. You'll be doing an exit ticket of these on Friday, and then next week you'll be doing your short cycle. So please, when you're working on your review previews, you get problems like this, take the time to practice them. They are a little confusing. Thank you guys for working hard today, listening. We'll keep trying these as the week goes on.